Today we're going to check two arresters that we just pulled off the line. Both of these 18 kV arresters were tied to a single phase tap that we built in 1994. The arresters that we used, it was exclusive to that arrestor for distribution. The primary line was 14.4 kV. These were single phase primary transformers, pole pots, and on a recent complaint that we had, lots of RFI that was affecting the cable TV company. So we went out there and looked with the 242 and the 243 and decided that both poles needed to be worked. We did that work yesterday, and these are the two arresters that we pulled off. So right now we have a Variac serving a neon transformer that can produce up to 15,000 volts at 30 milliamps. But it's enough to cause the arc in the arrestor and create the RFI. So right now the Variac is powered up, but it's at 0 volts. So now Sean will rotate the Variac and increase the voltage. And we have the 243 set at 144, and we'll be able to watch that. But this right here will become energized 15,000 volts. Okay, stop. Okay, so we're probably below 7,000 volts, and we're already arcing across this arrestor. So now we're going to move up in frequency. We're at 144. That's 330. Okay, and now we're going to move the frequencies. So we're at 330, 449. So we'll increase our gain. We're not anywhere near the rated voltage that we had on the arrestor, and it's screaming. We were pegging 799 megahertz when we were searching for it. So it's quite a bit of arcing going on inside the arrestor. Now we'll disconnect this and we'll connect the other one to see if it's exactly the same. Go ahead and power it off. And blue green button off. All right, now we have the second arrestor that was on that single phase tap. We have it connected to the neon transformer powered by the Variac. We have the Variac turned off. So let's turn the Variac on. It's set at 0 volts. Now we're going to start dialing up the Variac. And you can watch the 243. We have it set at 144 megahertz. Okay, we just went to peg and we're what at? So we're somewhere around 8,000 volts, and we've already started arcing inside the 18 kV rated arrestor. Now we'll move through the frequencies. We're going to bring our gain down. You can see I'm nowhere near full gain. I'm trying to get off of 10. At 144. 330, 449.
And what's your gain at whenever you're at not full peg on 144?
At 144, to get off full level 10, I have to be down at number 5 on the gain. Now we're going to go up in frequency, 330. Now we still see the same sparks, they just don't have the magnitude at the higher frequency. Now we're going to go up to 449. Still see the same sparks without that magnitude that we saw at 144. Now if I go full gain, let's go up, bring our gain up. There's 449. I don't have the gain up much more than I had it at 144, and you can tell that we're still making all this noise with about half of the primary voltage that we were delivering to these arresters. So both arresters needed to be replaced. Both arresters were producing RFI. Both were installed on that tap 28 years ago. And now the rubber gaskets are failing and water's getting in, moisture's getting in and causing that internal arcing. So we got to these before they failed, and we found it with our radar engineer radio frequency interference detectors. Thank you for your time.